Hi, Jason with Tormach. Today we get to test some new tooling. We've been working with AB Tools on developing a smaller version of their Shear-Hog insert. We've got them in the machine, we're ready to load them up and start doing some testing with them. So I'm quite excited. I love testing new cutters. It's fun just to put these things in and see what kind of performance we can get out of them. So if we kind of take a look at them here, this is our standard Shear-Hog insert. So you can see it's a really large insert. Very positive geometry, very free cutting, amazing roughing tool for aluminum. We wanted to take that same concept and just kind of shrink that insert size down a little bit. So you can see it's basically the same insert, but we just shrunk it. We wanted to be able to put more flutes on the cutter. Our goal was to be able to get like a 3-flute 1-inch cutter or a 2-flute 3/4. A big part of that was just to get the tool balanced. With a 1-inch cutter and a single flute cutter, when we started raising the RPM real high, we can start inducing vibrations into the machine. And by just adding inserts and balancing out those tools, we're able to run them substantially faster RPMs. In the testing and stuff, in the footage that you guys are going to get to see, you'll see that we're running this 1-inch cutter at 10,000 RPM and it sounds beautiful. So we're real excited about these new inserts and being able to do the testing and everything. So we'll kind of work through the different cut recipes that we went through. We tried big depths of cut, small depths of cut, big widths, small widths. We kind of just ran these things through the paces here to kind of see where the machine and the cutter were happy and would perform well. We have these cutters in 3 different sizes now. So we go all the way down to a 1/2 inch. The 1/2 inch tool is still a single flute. We were able to get the tooling size all the way down to a 1/2 inch. We are a single flute in that version. We also have our 3/4 inch, but we have added the modular head now, which gives you the ability to adjust your tool holders for added length. We also have the same style we carry in the Shear-Hog, which is the fixed shank in the 3/4, and those are all 2-flute inserts for that size. And then we also have a 1-inch 3-flute that is a modular head. I love testing cutters. I know I've said it, and I'm going to say it every time because it just makes me smile. We've got some little squares we're going to cut some pockets in, and we got some just big 6.5 inch rounds that we're going to face off just to get some long duration cuts. So let's jump in the cutting footage here and kind of talk through some of our speeds and feeds and the different tests that we ran these through. So the first cutter we're going to test is the 3/4 inch diameter modular head option. We have the 10 thousandths corner radius inserts installed in this cutter. So the first thing we're going to show is some facing. You'll notice on this first one here, I made a typo. I went to type in 40 inches a minute and I typed in 400. So we faced that block off at 135 inches a minute. The surface finish actually looked pretty nice on it. You could definitely see, but overall the surface finish still was pretty smooth. So the second block you see here is cutting at 40 inches a minute. We're just kind of playing with this to see how nice of a finish we can get with this cutter. The inserts that we are using on this again are the 10 thousandths corner radius. So if we really wanted to get a little nicer surface finish, we could bump up to a little larger corner radius and that would help us just kind of improve that surface finish. So in the last block here, this is finishing at 20 inches a minute. The surface finish on both the 40 inch and 20 inch a minute block were really good. Honestly, I'd probably lean more towards the 40 inch a minute finishing rate just to save some efficiency and stuff because it still looked really nice. So as we worked through the blocks, we had to rough out some pockets in these just as a test feature here. So we went ahead and we ramped into these at a 2-degree angle. We kind of played with the ramping and stuff. You'll see throughout the cut footage here, a couple of the ramps start to get bogged down and stuff a little bit. The magic numbers seem to be at 2 degrees at about 50 inches a minute. The cutter was happy and the machine was happy at that speeds. As much as we're testing the cutter in this video, we're also testing the machine and we're figuring out what the machine likes as well as what the cutter itself likes. Our roughing passes were a 200 thou depth of cut and a 200 thou width of cut. When I do testing like this, I program everything at 100 inches a minute and then I just drive the feed rate override bar to see where the machine is happy. And we ended up right at about 80 inches a minute on this. And it just sounded pretty good. Everything was cutting nice. And then you can see on the second pass here, we bumped up the feed rate to 93 inches a minute. And everything still sounded pretty good. I mean, we're definitely loading up the machine a little more, but it was able to handle the cut pretty well. On the second block, we were at 200 thou width of cut again, and we increased our step over to 250 thousandths. We're just seeing if the machine and the insert can handle that width of cut. As you can see here, we kind of loaded up a little bit more. Obviously, it's a bigger cut. We ended up being able to successfully run this at 85 inches a minute. Once we tried to push it up to 90, it just ran out of horsepower and wasn't able to successfully make that cut. So we kind of just let it run through a few cycles here to make sure that it could handle that cut over a long enough duration to be useful. So you can hear throughout the footage here, I just kind of keep playing with the speeds and feeds, and just driving it here with the feed rate slider bar and everything to see if we can get any performance or tweak it as we go. So you hear the spindle bog down here. I increased the spindle speed from 5,000 RPM up to about 6, just to see if we could lighten up the chip load and possibly push it a little faster. But it definitely bogged the spindle down a little more. We were getting out of that torque curve of the spindle, so we backed it back down to 5,000 RPM where it was happy before. So on block 3, we increased the width of cut substantially. So through this process, I calculated the material removal rates, and we were always right around 4 cubic inches a minute on a lot of the cuts that we were doing successfully. So when I increased my depth of cut, I backed up my width of cut to try to maintain that same removal rate as a starting point. So on this block, we increased the depth of cut to 350 thousandths, but we reduced our width of cut down to 150 thousandths. One thing you'll notice here on the second pass, you'll actually see like a real light foil or a burr forming over the top of the insert. The insert max depth of cut is 350 thousandths, and we were actually starting to roll material over the top of that insert. The cut sounded good and everything, but from a process reliability standpoint, that's beyond my comfort zone. I would definitely back up the depth of cut on this cutter to a maximum of 300 thousandths just to have some process and some margin of error there in case the stock is a little thicker than expected or anything. So this cut ended up being successful right around 60 inches a minute is where we were able to run this comfortably. We tried to push that up to about 67, 76 inches a minute, and it was overloading the machine there. One interesting thing throughout this whole process was we tested 3 different size tools and they all run the same insert, but I mean, we're really just testing this insert itself, and all the cuts and everything were very similar regardless of the size of the tool on whether or not it was happy. So on this fourth block here, we went kind of the opposite direction. We went a real light depth of cut with a bigger step over. So we went 100 thousandths deep at 350 thousandths over. The machine didn't really like this. It definitely got loaded up a lot more than it did even on the heavier depths of cut, on the bigger depths of cut, which I thought was kind of interesting. I thought we'd be able to kind of take a real light, fast cut, but that width of cut, it wasn't real happy. We were able to make this run at about 100 inches a minute successfully, but the material removal rates are quite a bit lower than when we're having those big depths of cut. And it just didn't sound as nice. It sounded like it was loading the machine more, and it just sounded like a more aggressive cut, where the others had a more consistent tone throughout the whole pass. You see some roughing here too, where we were trying to rough in a little bit faster. Even at that shallow depth of cut, we were unable to really go much faster than the 50 inches a minute. So the second test we did, we used the 1-inch diameter modular head unit again with the 10 thousandths corner radius inserts. And we just wrote a spiral pass to face off the whole top of this block. I wanted to do some little longer duration cutting just to see how they handled, like a nice long cut. So the first pass we made here was 250 thou deep and 250 thou step over. We ran the 1-inch cutter at 5,000 RPM. As you can hear, we're kind of just driving it. Again, I programmed it all at 100 inches a minute just so I could drive, and I had that flexibility to run the feed rate overrides and stuff to see where it ended up being comfortable and happy. When I tried to increase the spindle speed on this 1-inch cutter, it definitely did not like that. It really wanted to be in the torque right around 5,000 RPM. And with this cutter, we ended up right around 65 inches a minute. It's just where it was happy. With all these tests, we kept ending up right at that 4 cubic inch a minute removal rate. Just is where everything sounded nice and was performing well. With the change in diameters and the torque requirements of a larger and a smaller tool, it was pretty interesting to see that we always ended up at the same level. So it shows that the machine is consistent performance-wise. It's just how to utilize that with the different size cutters. So our second pass here, we increased the depth of cut again. We went up to a 300 thousandths depth of cut with a 200 thou step over, again at 5,000 RPM. As you can hear too, this pass did pretty well. As you can see, I kind of just grabbed a handful of chips here just to kind of take a peek. The chips were real consistent throughout this entire testing process we did. The shape of them and everything was the same regardless of depth of cut, width of cut. I mean, everything was real consistent. The insert geometry itself is very efficient and does a great job of making good quality chips, and they really do perform quite well. So with 300 by 200 cuts, We ended up right around 65 inches a minute again. So we were right back at that 4 cubic inch a minute removal rates. The next pass we did is we lightened up the width of cut quite a bit. We went down to an 1/8 inch, so a 125 step over. I was curious if we'd be able to really kick the feed rate up. So once we bumped the feed rate up here to about 110 inches a minute, you can hear that the machine just started, you know, the chatter started to kick in and we were really starting to load up the spindle. So we were able to actually run that at about 100 inches a minute. So that actually reduced our removal rate abilities a little bit by taking that lighter width of cut. The machine actually preferred the width of cut more. So with all the testing and stuff on the 1 inch cutter, the recipes I liked the most were the first two that we showed you guys. So about that 300th thou depth of cut to 200th thou step over. It seemed to be where everything was real happy. So here we go with the 1/2 inch diameter. This is the modular headed 1/2 inch tool. It has a 10 thousandths corner radius insert installed as well. We started out here around 6,000 RPM. And we started out with a 300th thou depth of cut with a 125 thousandths step over. So the second pass here, we kept the same depth of cut, but we increased the width of cut a little bit. See if we get a little bit more removal rate out of this tool. We stayed at that 6,060 RPM, but we increased the width of cut to 150 thousandths. And what we found with this path was we actually started to run the tool out of rigidity. You know, being a 1/2 inch diameter shank, we have being a 1/2 inch diameter shank, we have a lot less rigidity in the tool itself. So we were actually just starting to see flex in the tool itself. And if you look at the part finish here, you'll see the color variations across the surface, and that's directly related to the feed rate bar. So I was adjusting the feed rate, and when I would slow it down a little bit, it would take some of that load out, it would free that cutting up, and then it would allow it to get a little better finish and take out a little bit of chatter. You know, so that the tool itself was running out of rigidity on these test cuts. So the insert itself is very capable of taking the big cut, but on those smaller diameter tools, we also have to be cognizant of the tool shank itself. So here's another test we did. We did a 300th thou deep by a 75 thousandths step over on this 1/2 inch cutter. We're just seeing if pulling that width of cut out would lighten the load up on the cutter itself and just improve its removal rates. We were able to run it substantially faster at that speed, but we ended up right around the same removal rates again on it. And so we finished that cut up at about 85 inches a minute. So kind of just summarize again what we, the results of the testing and stuff is, these inserts are extremely versatile. We were able to do pretty light depths of cut successfully, big depths of cut, small step overs. The inserts really seem to handle everything we threw at them pretty well. We definitely noticed a performance increase from when we jump up in size from the 1/2 to the 3/4. The tool itself is just more rigid, so we're able to get more out of the machine with a little larger tool. But from the 3/4 to the 1 inch, we were able to maintain about the same removal rates and everything. So that really just comes down to your part size. What works well with the parts that you're making. All in all, I'm really happy with these cutters. They perform really well. We're able to pull off some really nice surface finish with the part when used for finishing. And we're able to very aggressively rough with them as well. One thing to keep in mind is these are pretty much a dedicated roughing tool. The insert geometry on them isn't a true 90 degrees, so if you have to do any shoulder milling with them at all, you will see a step on the side of your part. But if you need to come back and use them for a nice face pass, they do work excellent for that as well. Hope you guys enjoyed the video. For more metalworkings tips, tricks, and stories, you can check out our other YouTube videos, and please subscribe.